Hi, Mr. Richards here. Today's lesson is on lines. Our objective is to identify relationships of angles formed by two parallel lines cut by a transversal. Now, our vocab setup here, when two lines intersect in a plane and form right angles, they are called perpendicular lines. Two lines are called parallel lines when they are in the same plane and do not intersect. And we're asked to complete the graphic organizer. Well, we have our symbols for parallel, which two up and down lines that don't ever touch. And perpendicular lines, well, they're intersecting here at a right angle. So our definition in own words, we could say for parallel lines, two lines that never cross. A little easier way of understanding that. And you could say two lines that never intersect, or two lines that never cross, either way. To draw it, well, you could draw two lines with arrows at the end to represent that they're lines that never cross. And a real-world example of it, well, I'm hearing a train outside my window here, and actually, railroad tracks, when I think of it, those never cross. They just kind of keep going on forever. You kind of picture it going out in the distance. They just keep going forever and ever and ever and don't cross. Perpendicular lines, well, in our own words, we can say that these are two lines that do cross, and they're special because they form 90-degree angles. And I can draw that by drawing a straight line here and a line that intersects it at a right angle. And it's really important here that we draw in this right angle symbol. A little right angle symbol tells us that these are perpendicular lines. And a real-world example of this? Well, let's think. If I look down at the floor, I have floor tiles that are intersecting at right angles, so I'm just going to write down floor tiles. I know some don't, but the ones here, as I look down, do. Now we have a lot of definitions here, and you do need to learn these definitions. And so referring back here to this page is really important as you practice these to learn the definitions. And we'll run through these and we'll also practice these, but you do need to learn these. So whether you use flashcards or just do a lot of examples or listen to this over and over again, however you need to learn these key vocab terms, you need to learn them. Now, a line that intersects two or more lines is called a transversal. Well, here we have two lines. We have a line that intersects this. This intersecting line is considered a transversal. So this line L is the transversal, and you can see where the 8 angles are formed. Well, interior angles lie inside the lines. Interior angles lie inside the lines. If you're to put your arms kind of straight up into the air around your head's on the inside of those, that's inside. And likewise, if you look at this picture, your interior angles are inside the lines. Well, that's this space here that I'm shading in right now. That's the inside of the parallel lines. So that's why 3, 4, 5, and 6 are interior angles, because they're inside those lines. Now, exterior angles, again, they lie outside the line. So if you stick your hand straight up in the air, the areas just to the right of your arm or left of your arm, that's outside your arm. Well, this area here outside the lines, that's the exterior. So 1, 2, 7, and 8 are exterior angles, again, because they lie outside of these lines. Go ahead and erase these. Now, alternate interior angles are interior angles that lie on opposite sides of the transversal. When the lines are parallel, their measures are equal. Well, let's go back here to the inside, and that was in here. Now here is your transversal here. So we're looking inside and opposite sides of the transversal. Well, they're saying 4 and 6. Well, look, here's 4, here's 6. They're on opposite sides of the transversal on the inside. They're also saying 3 and 5. And notice how those are on opposite sides of the transversal. They're not saying 3 and 4 and 5 and 6. Those are adjacent. Those are next to each other. 3 and 5 and 4 and 6 are your interior angles, or alternate interior angles. And we can use the same logic for alternate exterior angles. Alternate exterior angles are exterior angles that lie on opposite sides of the transversal. The lines are parallel, their measures are equal. Okay, so if we go back to looking at the outside here, outside, here I am outside. And again, I have my transversal. Notice that I have listed 1 and 7. So 1 and 7 on the outside, one's on the left side of the transversal, one's on the right side of the transversal. They're on the opposite sides on the outside. Likewise, so is 2 and 8. They're on the outsides on opposite sides of the transversal. One's on the right side, one's on the left side. Alternate exterior angles. We'll go ahead and erase these as we read about corresponding angles. Corresponding angles are those angles that are in the same position on the two lines in relation to the transversal. When the lines are parallel, their measures are equal. 1 equals 5. 1 equals 5. Well, they're both in the top left position, so they're equal. Those are the same. 1 and 5 are equal, as are 2 and 6. Notice how they're kind of on the top right. And then we have 4 and 8. And those are kind of what I would consider the bottom left. And then I have 3 and 7. Those are kind of like the bottom right. So those are in the same position in the two lines. Top left, top right, bottom left, bottom right. That's what I would do when I'm looking at those. Now, before we get into our examples, let's take a look at the special notation that is used to indicate perpendicular and parallel lines. With the perpendicular lines, you can see the red angle, or the right angle that is red there. It indicates that line M and line N are perpendicular. And again, you can see the perpendicular symbol there. With lines P and Q, these are parallel, and the way you know this are the arrowheads in the lines. The red arrowheads indicate that lines P and Q are parallel. And again, you can see the straight up and down lines there. So in our little sticky note here, parallel and perpendicular lines, read M with the perpendicular symbol N as line M is perpendicular to line N. Just not M perpendicular symbol N. It's line M is perpendicular to line N. And with the parallel, it's line P is parallel to line Q. Now, in our examples here, classify each pair of angles in the figure as alternate interior, alternate exterior, or corresponding. 1 and 7, well, they're exterior angles. 1 and 7. And here is the transversal, the line that cuts the two. Well, here's what I would look for. Are they on the inside or the outside? Well, they're on the outside of the parallel lines. One's kind of on the left side, one's on the right side, which makes them opposite sides of that transversal. So they're alternate exterior angles. Now, what about 2 and 6? Well, once again, that transversal is the same. We have 2 and 6. Well, one's outside the parallel lines, that's 2. One's inside the parallel lines, that's 6. And they're actually on the same position. If you kind of tilt your head a little bit to the right, you can say, okay, that's the top right position in that set of 4. So is that. That's the top right position. So they're corresponding. They're in the same position on the parallel lines. Classify the relationship between angles 4 and 6. Let's look at those. We have angle 4 and angle 6. Well, we have our transversal that cuts the two lines here. Now, if we look for inside versus outside, here is our inside. So both are on the inside of the parallel lines. Well, we're assuming they're parallel. They don't have to be, but here, we'll just say they are. Either way, they're on the inside of the two lines. Now, are they on opposite sides of the transversal? I would say yeah. This one's on the left side of the transversal. This one's on the right side of the transversal. So the relationship here between the two we can record as alternate. They're on the inside, so interior angles. Now, when two parallel lines are cut by a transversal, special angle relationships exist. If you know the measure of one of the angles, you can find the measures of all of the angles. Suppose you know that measure of angle 1 is 50 degrees here. Okay, well, I'm going to write this in at 50 degrees. You can use that to find the measures of angles 2, 3, and 4. Well, if you think back to supplementary angles, if you have two angles, and this angle here is 50 degrees, and I'll try to highlight that here in red. This angle here is 50 degrees. Two angles that form a straight line like they do here are supplementary. They add up to 180. So if you're looking for the missing angle here, all you have to do is take 180 minus 50 to get 130 degrees. So 130 would be that missing one. Well, we can use that same concept up here. If angle 1 is 50 degrees, well, angle 1 and angle 2 share that straight line. And so 180 minus 50 again gets us 130 for angle 2, as it says in our little note there. Now, another relationship here are vertical angles. And if I just kind of look at it like this, if this is 50 degrees here, vertical angles are angles that have a common vertex, so they share that center point that I'm going over there. They're kind of opposite sides here. So these two angles here and here are vertical, which means they have the same angle measure, so 50 degrees. So angle 3 is also then 50 degrees, just like angle 1, as it says 1 and 3 are vertical angles, just like these two angles were vertical angles. And I'll go ahead and write in vertical here. Now it says angle 4 is 130 because 1 and 4 are supplementary. Well, that's the same concept. 1 and 4 are supplementary. So that's how you can find these four angles. And once you have these four angles, you can use the angle properties we're learning about in this lesson to be able to say, oh, these are corresponding, or alternate interior, or alternate exterior. Okay? Now it says, in the figure, how do you know that the measure of angle 5 is 50 degrees? Well, we're going to say that this is 50. How can we do that? Well, two ways. Two ways we can do that. The first would be corresponding. And what corresponds? Well, angle 1 corresponds to angle 5. They're in the same top left position, so they have the same angle measures. Another way would be alternate interior. You kind of look, 3 and 5 are both on the inside, on opposite sides of that transversal. So 3 and 5 are alternate interior. So measure 5 is going to be the same as the measure of angle 3. We're going to go over these now. A furniture designer built the bookcase shown. Line A, which is right here, is parallel to line B, which is right there. If the measure of angle 2 is 105 degrees, okay, let's go ahead and write that in. 105 degrees. Find measure 6 and measure of angle 3. Justify your answer. Well, sometimes if it helps you, you can pull these out. You have line A, and you have angle 2 at 105 degrees, and here's angle 6. What relationship do those share? Well, they form that straight line together. So you could say they're supplementary, which they are. So 180 minus the 105 is 75, and that's what they found here. Since angle 2 and angle 6 are supplementary, the sum of their measures is 180, so 180 minus 105 gets you, that's 75 degrees, and we can write that in for angle 6. Now, what about angle 3? Well, remember, these are both now on the inside, and they're on opposite sides of the transversal. One's on the right side of the transversal, 3's on the left side of the transversal. So that means they're alternate interior. And if they're alternate interior, then they are equal angle measures. So if angle 6 is 75, so is angle 3. And that's what it says in our description. On opposite sides of the transversal, alternate interior, they're equal. Measure of angle 3 is 75 degrees. Now what about the measure of angle 4? Well, 2 ways you can solve this. First, if you know that angle 3 here is 75 degrees, it looks like angle 3 and angle 4 are supplementary. So we can say, since angle 3 and angle 4 are supplementary, the sum of their measures is 180 degrees. And so the measure of angle 4 is going to equal 180 minus 75 degrees, which is 105 degrees. Now there is another way you can solve this. If we just kind of re-sketch this out here, we have angle 2 and angle 4. Well, 2 is 105 degrees. Now 2 looks to be in the bottom left of this set of angles. 4 is also in the bottom left of this set of angles. So we can use corresponding. We can say since angle 2 and angle 4 are corresponding, the measure are equal at 105 degrees. Now you certainly don't have to do both. It's good to know that both could work. All you need to know is one of the ways, but since both work, it's good to know as well. Now just to go over the last example here, in the figure, line M is parallel to line N. And I'm actually going to highlight those two. We have M parallel to N. If you ever need to redraw these to try to make sense, or use colors, or use colored pencils to try to make these make more sense, please do. Now it says Q is perpendicular to line P. And you can see that right there. The measure of angle 1 is 40 degrees. So we'll go ahead and write in 40 degrees. What is the measure of angle 7? So we're looking down here for 7. Now these can be a little bit hard to recognize at first, so let's go ahead and look at P, line P, which is our transversal. Again, I'll kind of color that in here to help us see this a little bit better. Here we have angle 1 at 40 degrees, and we need to get down there at angle 7. Well, that's not going to be easy to do. But if you look, we have angle 1 right here, and we have angle 6 down here. These are alternate exterior angles, are on opposite sides of this transversal. One's on the right side and one's on the left side. So they're saying 1 and 6 are alternate exterior angles, so measure of angle 6 is also then 40 degrees. Now, if we pull this out, 6, 7, 8, good thing it's not 7, 8, 9. The joke, 7, 8, 9. Anyways, sorry. The measure of angle 6 is 40 degrees. We have 7, which we're looking for, and 8. But 8 we know. How? Because of the right angle symbol. We know 8 is 90 degrees. Well, supplementary isn't just 2 angles that form a straight line. We could have 3 angles that form a straight line. Angles 6, 7, and 8 form that 180 degree angle. So 6 plus 7 plus 8, the measures of those angles, has to equal 180. Well, you know 6 is 40 degrees. You don't know what the measure of angle 7 is, but you know the measure of angle 8 is 90 degrees. So what they did is said, okay, well, 40 plus 90 is 130, plus whatever the angle 7 is, needs to equal 180. Well, 130 plus what is 180? Well, if you subtract 130 from both sides, you get the measure of angle 7 is 50 degrees. And that's how they find that. So there's always a way to piece these together. It may be hard to see at first. Use colors to help you, or redraw the picture. Protractors won't help here. These are not always drawn to scale. So you're going to have to try to visualize as best you can. And the more you practice these, believe it or not, the better you'll get. That's it for this lesson. Good luck.